some string operators. So plus and times are operators. 2 plus 2 is 4. 3 times 2 is 6. They're also operators over strings. So you can have a string plus a string times a constant, an integer, a string plus an integer. And what happens? Well, string plus string does string concatenation, as we've seen. And string times integer, ABC times 3 does ABC, ABC, ABC. So it means repeat this string that many times. But you can't do string plus integer. That makes no sense, and you can't convert. It says you can't convert an int to a string implicitly, although it misspelled implicitly, because Python's trying, or Python here is trying to add this string to this integer. It doesn't know how to add strings and integers. You'll get a different but similar error in standard Python. What would happen if we tried to multiply a string times another string? And what would happen there is you can't multiply strings together. So it complains on that line as well. So we see that the meaning of plus and times are different for strings than for integers. In is pretty straightforward. If you have a string in another string, the in is an operator that will be true or false depending on whether this string occurs inside that string. So when we run this, ring is in fact in strings. Wow is of course not in amazing. Yes is not in yes because this test is case sensitive. So the capital Y will not match the lowercase y. This last one's pretty interesting. The empty string, which has no characters in it, is it in the string? No way. And it is. In fact, it occurs between the starting quote here and the n, right there. There's an empty string. And between the n and the O, there's an empty string, between the O and the space. So there's a whole bunch of empty strings, as it turns out, in this string. Dealing with empty strings is one of the more confusing things probably for a new programmer. But trust that the empty string is, in fact, in every string. So to continue now, there's another powerful operator we need to know about, and that's the indexing and slicing for strings. So to begin with, if we have a string, A, B, C, D, E, F, G, we can print it, and we'll get, of course, A, B, C, D, E, F, G. But we can print S of 0. S, we pronounce this S of 0. The brackets surround, or the index is what we call this 0. And in Python, as in most programming languages, indexing starts at 0. This is character 0, character 1, character 2, character 3. The first character is at index 0. So this will print out an A. Oops, this will print out an A, a B, and a C. Now this one here, what's this going to do? S of len of S minus 1. You might think it would print out the second to last character, which would be a G. That's not what's going to go on, because we start at 0. If you start at 0, then the last character would be at the len minus 1. So this will in fact be the H. So what is that len of S? Well, for any string, this is going to crash because there is no character there. That's 1 beyond the end of the string. So when we run this, we sure enough see we get ABC. We get the H, the last one. And right here now, we crash. It says string index out of range. This here is the index, and it's 1 larger than is legal for that string. And that would be true no matter what string we use here. When we run, we will get the last character, and let's make the last character say like a Q. When we run, we'll have the last character will always be, there it is, always be right here at len of S minus 1. And if you try to go in at len of S, you will crash. Okay, negative indexes. So Python, unlike some older languages like C and C++ and Java, will allow you to have negative indexes where you can say -1, which would mean come off the right edge, and -1 would be H. You couldn't have 0 be H because 0 necessarily is from the left edge, the first character. Hence, -1 is the first character off the right edge. This has the happy effect that anytime you have an index of len of S minus some value, you can just omit the len of S and just have the minus value, and that will be the same character. Len of S minus 1 is the last value counting from the left. S of minus 1 is the first value counting from the right, and those are the same value. So this is an H, this is a G, and there it is, H and G. Okay. Slicing a range of characters. So when you slice, you can take out a portion of a string, unlike where we just index a single character where you give one index of the character you want. So the way slicing works is very similar to how we've seen range work before. If I said range of 0, 3, it means start at 0 and go up to and not including 3. If I said range of 1, 3, start at 1, go up to and not including 3. So here the syntax is a little different. We don't say range. We have brackets instead of parentheses. We have colons instead of commas. But the idea is the same. Start at 0, go up to and not including 3. Only these are indexes. So we're not going to get 0, 1, 2, but we're going to get s of 0, s of 1, s of 2. So this, s of 0, 3, is the string ABC. Here it's the string AB. Here it's the string I'm sorry, it's ABC, BC. Here it's just the string C because you start at 2, which is 0, 1, 2. It's the C. You go up to and not including 3, so it's just the C. And finally, this last one, start at 3, 0, 1, 2, 3. So you start at D, but you go up to and not including 3. So you stop before you even start. This is legal. It won't crash. It's going to be the empty string. And we see when we run this, we see 0, 3 was ABC, 1, 3 was BC, 2, 3 is C, and 3, 3 is right here. It's the empty string, not crashing, the empty string. Okay. You can also slice with default parameters. So when I slice from 3 colon, notice I've left off the second parameter. So we're starting the string at 0, 1, 2, 3. So we're starting at D, and what do we go up to? Well, if you leave off the second parameter, you go to the end. So we'll see that we went all the way to the end of the string, D, E, F, G, H, which is to say it's the same as going to len of s. And when I run this, you can see that that was unmodified. And you might say, wait, we said len of s minus 1 was the last legal index, which we did. So the len of s here is valid because you don't include the last index in a slice, as we didn't in a range. So the last character we'd actually include would be at len of s minus 1. But again, you can just leave that off, and it means the same as if it was there. If you don't include the second value, go to the end of the string. If you don't include the first value, it's naturally the same as if you started at the beginning, which means if you don't include either value, it means start at the beginning and go to the end, which means copy the string completely. There are times when you'll want to do this, but with strings, not so many, because as we'll learn, strings are immutable. With mutable data structures, it's a way to potentially copy. So it's a way to copy a list, as we'll see in the future. It's not the clearest way, so I'm not a big fan, to tell you the truth, of this particular syntax. But nonetheless, people use it, and you have to know what it does and why it does it. Slicing with a step parameter, this is much less common, but as it says, perfectly okay. Just as in a range, you can give a step. In a slice, you can give a step. So unsurprisingly, 172 starts at index 1, which is the B, goes up to and not including 7, stepping by 2s. And notice how these are stepping by 2s, and then this time stepping by 3s. So there you go. You have steps if you want them. Reversing a string. So when you reverse a string, there's a couple ways to do it. This syntax right here works. I have a string, A, B, C, D, E, F, G. And one thing you can do is default start at default end, step by -1. I think that this is a very confusing usage, but it actually will work, and it will reverse a string, as we see right here. This usage right here uses the reversed built-in function. The problem with the reversed function is this. If I say s is ABC, and then I print the reversed of s, I don't get what I'd hoped for. I get this reversed object, whatever that is. And I can go ahead and do some magic at this point. We'll demystify this later, but some magic which actually takes that reversed object and turns it back into a string. But this is also confusing, especially for a novice programmer. So basically, neither of these, neither this nor this, read very cleanly as far as I'm concerned for reversing a string. But reversing a string is a pretty common thing to do. So what do? You create your own function, reverse string. Put whichever of these two ways you prefer inside the function and return that value. This is still not very clear, I think. However, at least inside this function, it's very well documented. This is called self-documenting code because there's no question that we intend for this right here to reverse a string. So first, it's very well documented. Second, this encapsulates the unclarity, if you would, because from now on, when we call it, you call reverse string of s, which, as the comment says, is crystal clear because it is. Certainly, this reads very nicely that we are reversing this string in a way that this does not. So this function, reverse string, is not built into Python, but we recommend that you add it in the same way that, say, almost equal is not built in, but you should probably add it pretty much every time you're coding anything. And so that is reversing a string, and with that we've seen the end of indexing. We've already seen in, plus, and times, and that brings us to the end of these string operators.